Check, 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 check. Yes. Morning, everyone. I think all of you are back from the Bali holidays. In the last session, there were very less people, very less of you. So there are more now. Hopefully, again, we will have all the students, all of your classmates. Of course, today we won't be waiting for all of your classmates to join. Uh, we'll start in a minute. Okay, all right, let's start. start. Yeah, it's already 10:35. Yes, so I'll share my screen. In the last session, we had dug deeper into regression and tried to understand what is regression and how to calculate the equation to regression line, equation of the regression line, based on the same example data which we were using to discuss correlation, to understand about correlation. Yeah. So we did this, we did all this. Yeah. We also explained, we also discussed what is meant by best fit. What is meant by best fit? Okay. Yes, any comments? Any comments? I think somebody unmuted, but I'm not able to hear it. Okay, if you're facing problems, you can write in chat also. Then we will look into it. Yeah. So, what is meant by best fit? So, we discussed when we have a set of data on this or this, the first one or the
So
second
you're not audible
graph.
properly.
So, not audible. Check, 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 check. The indicator is showing that my voice is getting registered. Wait a second. Okay, what about now? Is it better? Check, check, check. Is it better now? Okay, so this much only I could manage. Or, yeah, I can remove the headphone. And when you are speaking, I'll remove the headphone again. I
So
have
your voice
received
is
this feedback.
breaking actually.
Okay. What about now? Is it breaking still?
Yes, sir.
But it is better. I have removed the headphone. Is it better?
Yes, sir.
Okay. Okay. So yeah, without the headphone also we can manage. Actually, it's more comfortable for me without the headphone. Yeah. So okay. So we had this. So we were trying to discuss regression. We are going deeper into regression. So in the last session, day before yesterday, we did three things. That is, we tried to understand. We say that regression line is the line of best fit. So what is meant by best fit? That we discussed in last class. And of course, the regression line will have an equation like any other line. Yeah, y equal to c, where m is the slope. Yeah, that is this slope. The inclination actually, slope measures the inclination. Yeah, by the way, I missed slope is also called gradient. Gradient. In many books, you will see gradient instead of slope. Slope or gradient. They are the same thing. So how to find out m and how to find out the c? What is this c? This constant? It is the y-intercept. That is the regression line. Where is it cutting the y-axis? This distance, y-intercept. Yeah. Y. Okay. This distance. How to find out m and how to find out c? we saw. Yeah. To find out M is a little involved. Yeah. First of all, for I think four of you, 3 or 4 of you who were not there. So what is meant by best fit? See, these are the data points. These are the examples. So we can take distance of these apple points from the line we are considering. Yeah, from the line we are considering. As of now, we don't have the regression rate. So we are trying out different lines, say. So this is one of the lines. So what is meant by best fit is when we draw the perpendicular distances. We are just trying to measure the distances of actual points from the line we are considering. This point coincidentally is on the line. And similarly, this one. So if the square of these distances, let us call them E1, E2, E3, like that. So the square of these distances should be minimum. If it is line of best fit. If there is some other line, say some other line like this, for which the square of distances from the points, see here is this distance E4, here is this distance say E5. Okay. From this point, distance from this line is different perpendicular distance. Let's call it E6 and E7. Yeah. There is, yeah. Actually, in the earlier line, let us call it L1 and this L2. L1 point was on the line. Yeah. And this L1 green line, one actual point was on the line. So the distance for that actually is 0. 0, I'll write it here. Otherwise, when I write distances for the next line, you will say there are 4 terms in line 1. So 1 point was on the line L1. So distance of that point from the line is of course 0. Yeah. Now considering the distances of actual points from line L2, this L2, that is E4 square plus E5 square plus E6 square plus E7 square. Yeah. So if L1 is the line of best fit, it should be less than this distance, this sum of square of distances. Actually, if L1 is the line of best fit, the square of distances from actual points to this line should be less than from any other line. Any n number of lines you can draw. If L1 is the line of best fit, then the square of distances from the actual points to this line will be minimum. Then only we will call it the line of best fit. And then only we will say it is the regression line. Yeah, linear regression line. We are discussing linear regression. And higher classes or those who are more interested can explore further. There can be non-linear regression line also, like a curved line, a sine curve or cosine curve or anything exponential curve also. You can try to fit in the data points. The basic criteria is the graph should fit very well to the data points. Yeah. So here, basically, when we talk about regression, we talk about linear regression only, fitting a line to a set of data points. Okay. So that is meant by best fit. Is this clear? What is meant by best fit? Okay, voice is not clear. That was from before, I think. So now we are using without the headphone. uh, yeah. So what is meant by best fit is clear to all six of you.
Your voice is getting break.
Uh,
Your voice is not clear basically.
Bluetooth mode.
yeah. So,
Connected.
could you repeat your response? Let's see if we can use the speaker, or I'll put on the headphone. Devendra was saying something.
Your voice is not clear.
Still not clear.
Yes.
Okay, then what? Ah, uh, the signal also shows it's not the optimal signal. Let me try out uh, Vodafone. This is Geo actually.
So Vodafone is doing worse than Jio.
But we can't say in which area which connection will work when. But still, I mean, when we have an option, or in the next session, I will try to use the Institute Wi-Fi, which also I hear is yeah, may have some issues. Now the thing is, if I receive any phone call, it will get disconnected for 2 seconds. Yes, sorry about that. You were right. The Vodafone connection is worse. It's showing 3G actually, not even 4G. So we will have to work with this somehow. Uh, okay. Okay. Okay, so that is what we mean by best fit. We call regression line is the line of best fit. That is what we mean by best fit. That is the distance of actual points from the line. Square of those distances is minimum than any other line. Then how to calculate the coefficients? Coefficients means this M and C. How to calculate that? Yeah. In this equation, we just have to calculate M and C. Then for whichever value of X we put, we will have a value of Y. To be able to do that, we need M and C. Then we say that we have the equation of regression line. So how to calculate M? Now M, the slope or gradient of regression line is closely related to correlation. Yeah, correlation coefficient, which we discussed earlier. Actually, that is why we discussed correlation coefficient before discussing regression. Yeah. So we use correlation coefficient to find out this slope. This slope is actually correlation coefficient multiplied by standard deviation of Y divided by standard deviation of X. Yeah, it is that simple. Then what we do, we want C. Yeah, to find out C, now that we have M. Yeah, we calculate M using the correlation coefficient. Is this clear? This formula is clear. Formula to find the slope is equal to correlation coefficient multiplied by standard deviation of Y divided by standard deviation of X. Is this formula clear? You have
not shared your screen yet.
Screen. Okay. Okay. Yeah. Now it is shared. Sorry about that. Yeah. So next step is we are trying to find out this M. At the top, you can see Y equal to mx plus c. So what we want to do, all we want to do is find out M and C. First, we find out M. So how to find out M? The formula to find out M, we use a correlation coefficient for that. M equals this correlation coefficient, which is the small r, this one, multiplied by standard deviation of Y divided by standard deviation of X. Okay. This way we calculate the slope or gradient. M. After calculating M like this, we will substitute M in this equation of Y. Yeah. Then to calculate C, what we will do is we will put the means of Y and X in this equation. Means of Y and X in this equation. Yeah. Mathematicians have found that whichever line of best fit we take, that line of best fit will definitely pass through the mean of X, wherever that mean of X is. Say, suppose it is here, and mean of Y is, suppose, say in this case it is here, it comes out to be here. So the point we get, this point, the intersection of mean of X and mean of Y, yeah, So this point, the line of best fit will definitely pass through this point. Yeah. So actually all this line drawn here will not be line of best fit in this case. Line of best fit will be the line which passes through this point, mean of x, mean of phi, mean of x and mean of phi. It has to, line of best fit has to pass through this point. Okay. Then the other criteria remains the same. The distance from the actual points to this line will come out to be minimum. The square of those distances will come out to be minimum. Okay. So as we know, the line of best fit will pass through mean of phi and mean of x. We can put mean of phi and mean of x in this equation, y equal to mx plus c. Yeah. And in that also we already have, the only unknown then remains is c. Okay. Then we can see also. So for those of you who have forgotten, in the last session, many people had forgotten how to calculate correlation coefficient. But we quickly revised then, and we are again revising today for those who, okay, yeah, participation has increased. Yeah, so those who were not here in the last session, how to calculate the correlation coefficient, R, a small r. Yeah. Very soon we will have a capital R also in regression. So please keep in mind the correlation coefficient is denoted by small r. Yeah. So correlation coefficient we calculate like this using covariance divided by standard deviation of one variable multiplied by standard deviation of other variable. Like this formula you have here. Okay. This formula. Okay. Now how to calculate covariance then? Using this simple formula. Covariance is how the variables are pairing together. So we calculate it like this. Now, if you want to be more precise, you can put a subscript I here. So covariance is summation of the product of these differences for each data point. For each data point of x, we will take x1 minus x bar multiplied by y1 minus y bar. Yeah, then we will have that product. Then we will add x2 minus x bar multiplied by y2 minus y bar to that. Yeah. So all those products we will add. That is what the summation sign shows. We will do a problem. We will do an actual problem using the same old data. Okay. So this is how m is calculated. After calculating m, we put m in the equation, the regression equation, and in place of y bar, y and x, as we know, the line of best fit, that is the regression line, will pass through the mean of phi and mean of x, the point which represents mean of phi and mean of x in the graph. The regression line will pass through that point. Yeah, mathematicians have proved that the line of best fit will pass through the mean of the variables. Yeah. So that those means we can put in this equation, y equal to mx plus c. So m we have calculated using this formula. Y we are putting y bar, the value of phi we are putting as y bar, the value of x we are putting as x bar. The only unknown which remains is c. Yeah. So we can easily calculate c. Everything else is known. So we can do a little bit of simplification or rearrangement, we can say, and calculate c. So that is how to calculate c. Now, yeah, we took this example, these are not actual calculated numbers. So you can try to do this. You can try to arrive at the regression equation for this data for our temperature and sale of pakoras data. What will be the benefit of using this data? There is at least one benefit. You already have calculated the correlation coefficient. Yeah. In order to calculate correlation coefficient, you had already calculated standard deviation of X and standard deviation of Y also. Yeah. Do you remember? Do you have it in your notes? See, here we calculated on Excel also. Yeah, this is the same data. This is the same data. Before Diwali holidays, before midterm, we were discussing this correlation. We had started with correlation with the same data set, this data set. Okay. Now we are trying to find a regression line to fit this data. Regression line to fit this data. Okay. So, what is the equation of regression line? Y equal to mx plus c. Shall I think it is getting too congested, which is not a good thing in mathematics. Although while revising, it looks very nice, but while understanding, if it is too cluttered or too congested, it's not a good thing. So we'll write things again. Yeah. So this is the line of regression, y equal to mx plus c. All we are trying to do is find out m and c. How do we find out m? Using the correlation coefficient r multiplied by standard deviation of y divided by standard deviation of x. Once we have m, we put it back in the equation, the actual value of m. After finding out m, it will be a number, right? Say m comes out to be 4, for example. So we will put 4 in this equation and y equal to 4x plus c. Still, we want to find out c. We have to find out c to call it a equation, to be able to find out y values whenever we put some value of x.
मम्मी आज बैंक पे जाने आती
पियो यार पियो
मैं याद से तेरे फोन दे था
Pradeep has some doubt. Yes, Pradeep. Okay, so that was unmuted. Okay, yeah. So we still have to find out C. So how to find out C? As I said earlier, as we discussed earlier, the regression line will pass through the mean of y and mean of x. So if we put mean of y and mean of x, say y bar equal to 4x bar. The only thing we do not know here is C. Say mean of y is, last time what example we took, mean of y suppose is 1800 and mean of x is 22. So like this we took an example. Sorry, the only thing we do not know here is C. From here we can easily calculate, which comes out to be 171. Okay. So this much we discussed in the last session, and we tried to find out the regression line, the actual regression line for this data which we started with. So part of the work is already done, because for understanding correlation coefficient, or Pearson's correlation coefficient rather, we will study two more correlation coefficient, which are not as clearly quantitative as this data. Rank, etc. is involved. So if the value is not given, value of the variable is not given, the variable is only ranked sometimes, ranked, R-A-N-K-E-D. So then also we can find out some sort of correlation coefficient. Those correlation coefficient we will discuss sometime later. Okay. So here we are concerned with, we are using Pearson's correlation coefficient, which is the simplest, probably the simplest. Yeah. So what to do? We have these x values of temperature, y values of scale of pagoda. So first we calculate the means of x and y, means of y here. Then we essentially want to calculate the correlation coefficient. For that we are doing all these things. First, xi minus the mean every time. So here it is 25 minus the mean, 22.75. Here it is 28 minus 22.75, which comes out to be 5.25, like this. For 20 also, 20 minus 22.75, and for 18 also, 18 minus 22.75. Then we have calculated x minus x bar like this. Then y minus y bar also similarly we have calculated. Y minus y bar means here this 1500 minus this 1800. 1800 is the mean of y. So 1500 minus 1800. Okay. So this is minus 300, like that. So let me put on the headphone again and try, or is it very clear? Is the voice clear, or do you want me to try headphone again? Because when I hear back the recordings with headphone, it is very clear. Yeah. Check, 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 check. Check, 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 check. Yeah, now it is, I think, audible. Yeah, I can hear myself actually. Okay, so screen is also now shared. Yes. Yeah. So yes. So x minus x bar, we have these values in column G and column G, and y minus y bar we have in this column H. Yeah. Then we multiply x minus x bar with y minus y bar. Why do we multiply? We essentially want to calculate correlation coefficient. For that, covariance is required. Right? So x minus x bar multiplied by y minus y bar. This is this summation. Yeah, the summation we saw. So we are trying to do this thing, trying to find out the slope. In fact, for that we want to find out the correlation coefficient first. Yeah. Then to find out correlation coefficient, this is the formula: covariance of x and y divided by standard deviation of x and standard deviation of y. So for covariance, we had to calculate x minus x bar multiplied by y minus y bar. Here, towards the right side, you can see this formula: x minus x bar, y minus y bar, multiplication of that, and summation of all those numbers. That's what we did. X minus x bar, y minus y bar, all these products we got, and at the end we summed it. Yeah. And then divided by n. N in this case is 4. There are 4 values, right? 4 values of temperature and 4 values of sales of pakoda. So this summation of x minus x bar multiplied by y minus y bar divided by n, that gives us this covariance. Minus sign just shows that they are varying in opposite direction. When temperature is up, sale of pakoda goes down. When temperature is down, sale of pakoda goes up. Yeah, that is intuitively also logical. ठंडे दिनों में जैसे आजकल ठंडी पड़ रही है, so we also want to have more and more hot food like pakoda, tea, soup, etc. Yeah. So that is logical. So this is the covariance. Now we want to calculate the standard deviation. Why? Because to calculate the correlation coefficient, the denominator is standard deviation of x multiplied by standard deviation of y. So what is, how do we calculate the standard deviation of x? X minus x bar, which we have here, those values we square and add, yeah, square and add, which gives us this value 62.75, and that value we divide by n. We divide by n and take the square root. That is how we calculate the standard deviation. Standard deviation of x comes out to be 3.96. The same way we calculate the standard deviation of y, which comes out to be 4.9. Then again going back to the formula, substituting the formula, covariance we have, standard deviation of x we have, standard deviation of y we have. Substituting all that, we calculate the correlation coefficient like this: covariance divided by standard deviation of x covariance divided by standard deviation of x and standard deviation of y. Yeah. Yes. So covariance divided by standard deviation of x multiplied by standard deviation of y. Right. So this is the correlation. This is this r value here. So to calculate the slope, we have to multiply r with this ratio. So how will we get that? Slope of regression line equal to this correlation multiplied by standard deviation of y. That is the variable we are trying to predict. Yeah. Variable y means the variable we are trying to predict. X is the variable based on which we are trying to predict the y variable. That is the definition. Yeah, just interchanging x and y, or calling it instead of x and y a and b or p and q should not confuse you at all in any way. Yeah. Y is what we are trying to predict. X is based on what variable we are trying to predict. Yeah, the y variable. Y variable is called the dependent variable. X variable is called the independent variable. The concept should be clear. Then whatever name you come across, whatever nomenclature you come across, will not confuse you. Yeah. So this is the slope of regression line. Oops. Minus 122. Yes. This coefficient is correlation coefficient is negative. Yeah. And of course, standard deviations will be positive. So K11, that is this value, 494.97 divided by this cell, that is 3.96. 492.94.97 is the standard deviation of y, and 3.96 is the standard deviation of x. Yes. So slope of regression line is this. Now we have slope, we have m. Now what should we do? We have m. Now we will substitute m and m in the equation, of course, m and y equal to mx plus c together with the means of x and y. Why? Because the regression line has to pass through means of x and y. Like this, what we have done here, we will substitute in the regression line. So now our regression line, if I write it like this, y equal to mx plus c, that is the general equation. Now we have reached m equal to minus 122.709, and as regression line has to pass through the means of the variables, we substitute the means in the equation. Yeah, this comment is visible. Now what we do is the means of y bar equal to mean of y that is equal to, we can go back to the table. Yeah, this is the mean 1800. Oh, it came out to be 1800. Maybe somewhere unconsciously I had remembered 1800. So in the example also, while doing in the whiteboard, this we took 1800 only somehow. Yeah. And mean of x equal to x bar, which is again somewhere near what we took. We took 22. Actual mean was 22 point something, 22.75. 22.75. Yeah, so it is 22. I am writing more because some people are not able to hear the voice clearly, so that is why I am writing more here. Now substituting mean of y in place of y, mean of x in place of x here in this equation. So if we substitute that, then it will be y bar, that is 1800, equal to m, that is minus 122.7092. Obviously our assumption of m, my assumption of m was very off the mark. In the example I had taken 4, it's nowhere near 4. Yeah. So m multiplied by x bar, that is 22.75 plus c. So if we rearrange the terms to find out c, so c will be equal to 1800. This we can do minus, or we can simplify a little bit, then try to find out c. So this will be yeah, 1800 equal to minus 2791.634 plus c. Okay. Now we can try to find out c, which will be equal to 1900 plus 2791.634. Yeah, it will go to the other side. So c's value will be 4591.63. So what will be finally our equation? Our regression equation, y equal to mx plus c, it will be y equal to m, that is minus 122.70, or you can write 7092, the full thing, or 70 is okay, mx plus positive 4591.63. So this is our regression equation. Yeah. Is this clear? The calculation of regression equation? Yes. Yes. So this is the result of all our hard work so far in regression. So now if we want to, as the problem posed, the problem was posed for 29 degrees Celsius, what will be the sale of pakoda? Yeah. In the last session, we wanted to find out the uh, equation to regression line here. And if the temperature, that is the x variable in that case, if the temperature is 29 degrees Celsius, what is likely to be the sale of pakoda? Of course, we cannot predict with certainty. We can actually never predict with certainty the future. Yeah, but we can have some idea. It is much better than saying that it could be anything. The sale could be anything. Based when we have past data, when we have past data, in this case we have past data, we can use the past data to prepare better. So if it is 29 degrees Celsius today, we can say that the sale of pakoda will be M, that is minus 122.70 multiplied by 29 plus 4591.63. So that is yeah, 1033. We can say that 1033 rupees worth of pakoda will be sold today if the temperature is 29 degrees Celsius. If the temperature is 0 degrees Celsius, then what will be the sale of pakoda? The temperature is 0 degrees Celsius, freezing point. What will be the sale of pakoda? Anybody? Check, 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 check. Yeah, I'm audible, right? I mean, as much as before, may not be very clear, but still. So the question I'm posing is, what will be the sale of pakoda if temperature is 0 degrees Celsius? Zero degrees Celsius. What will be the sale of pakoda? You have the regression line in front of you. Who can answer? Who can try? Yes. Danish, Devain, Harsh, Mohit, Pradeep, Tanvi, Vaibhavi. See, I know to calculate you will require around half a minute, but here I have taken the value 0. I have given the value 0, so it should be even easier. Yeah. I expect at least, I mean, I expect all of you to be able to answer this. If temperature is 0 degrees Celsius on some day, what will be the, we have the regression line in front of us. Okay, I'm connected still. Yes. Still, the capital R square, the concept of how good is the regression line. We have found out the equation to regression line. That means we have found out the regression line. How good is a regression line in this case? If we find out that the regression line is not suiting the data that much, it's not the fault of regression line or anything we did in the process. Yeah, it is the way data is distributed. Maybe a line cannot be fitted very well in the data given. It can happen sometimes. Yeah. That to what extent the regression line actually represents our set of data, our data set, that is measured by something called as R square, capital R square. Okay. That we will definitely discuss now in the next session, because everything else has been discussed. Yeah, that is remaining, and few different kinds of correlation coefficients other than what we discussed. We discussed Pearson's correlation coefficient, but when the data is ranked, yeah, the actual value of the variable is not given, but they are ranked. 1, 2, 3, 4 ranking is given. Then also we can find out one of the variable is ranked and one of the variable is the way we have discussed so far, numerical or nominal, as we say. No, nominal is different. Okay, now one of the variable is the way numerical we have discussed. So different kinds of variables. Have we discussed different kinds of variables? Nominal, ordinal, ratio. Have we discussed that? Or in any other subject you have discussed that? You have studied that? Actually, ordinal comes closer to ranking. Nominal is just names, qualitative data, like blue, green, names of color. It need not have any ranking or a relation or measure of distance between two values of variables. So that we can discuss very quickly later. Those are simple concepts. Unless we have already, I think we have already discussed different types of data. Yeah, just check your notes. Otherwise, we will discuss those 4 basic types of data we use in further statistics. So this is regression. So who will be able to explain about regression in the next class? Who will be able to explain to your classmates what is regression and till the point we have discussed so far in regression. I think we have devoted for regression, we have studied correlation first. So around at least one session was given to correlation, maybe more than one session. So correlation, after correlation, we have revised correlation, then regression. So far, except for capital R square, we have done everything, and we are using only 2 variables, one X and one Y, one independent variable and one dependent variable. So things are simpler. When we have more variables, Y may not depend on only X, it can depend on more number of variables. Yeah. Then also the concept remains same, only the calculation of the slope. Then there will be a slope for each of the variables. it increasingly becomes difficult to actually visualize. Yeah. One variable, two variables, we can see a plane, we can visualize a plane. Yeah. If there are two variables, two independent variables, that means if there are three variables in all, we can try to visualize a solid space. We can visualize a three-dimensional space. Then when the number of independent variables increases beyond 2, then it is difficult to visualize as such. But that's how we use mathematics and mathematical concepts. Some part of it are visible, we can easily visualize, then we project it. Then we try to find out ways to see if our projection or our predictions were correct. Yeah, so that is what we do. And that's what mathematicians do. Some of you who will become mathematicians, who will enjoy doing that kind of work. Yes, so we will end today's session here. Of course, I mean, it is not very good that you're not responding even for this simple answer, a simple question. For 0 degrees Celsius, what will be the sale of pakoda? So you can just put 0, x equal to 0 in this equation. And do tell me in the next session, all of you. So in 1 or 2 more sessions, we will have discussed the entire topics in your syllabus. Then we will start revision. We'll start revision. But if you do not respond, there cannot be any revision, because revision I will start from the point you have understood, the common point which all of you have understood. Say in geometric mean, to what extent all of you have understood. Maybe you have forgotten an entire thing, that is also okay sometimes. But most of the topics we will start with what you remember till the point everyone remembers, then we will start from that point and have 1 or 2 problems for each topic we have discussed. Yeah. And you can also ask your doubts, all your doubts. Yes. All right, then, thank you. Not getting the feeling that you're still connected actually, but thank you for joining, at least in the first part. Yeah, Devin was pointing out.
Thank you, sir.
Thank you. Yeah, so some of you are active. Very nice. All right, see you in the next session.
Bye, sir.
Bye.